Alright, hello and welcome everyone to the second lesson of indices. So far we've learned what an indice is, or what an index is, or alternatively what potentially a base is, right? The same word, they mean the same thing. It's the little number at the top right hand corner. And we've also talked about what the base is, right? The base is just a normal number, the numbers we're used to seeing. And the reason why you don't typically see an indice with your normal numbers is because the indice or the index just happens to be the number one. And when that's the case, you can sort of just ignore it. You don't actually have to write it. Oh, she's about to get on the dragon. No, she's doing this. No, the dragon's really cool to ride, by the way. Anyway, so on to our next lesson. In this lesson, we're going to be covering two new skills, and that is writing algebraic expressions in what we call expanded notation, and we'll learn to do the opposite, which is writing them in index notation. So they're the two skills: expanded notation, index notation. So let's get into what will be our second lesson. All right, so in this lesson, expanded notation, index notation, let's get cracking. All right, so hopefully you have your maths equipment with you. If not, pause the video. You'll need your maths book and you'll need some sort of pen/pencil. That's about all you're gonna need. Calculators are not necessary. All right, so in your, hey buddy. So in your books, so let's start off by getting our notes in. We're gonna start with expanded notation first. I believe I've got, 5 examples for you in total. So what I'm going to do is I'm going to go through these examples for you, show you how to do them, and then I'll get you to pause the video and get all of this copied into your books after. All right, so the first one, we want to write the following in expanded notation. So the first one, we have 2 to the power of 3. It's currently in what we call index notation. It's been written with an index there. If we're going to write this in expanded notation, the way we'll do it is 2 to the power of 3 is, well, we have 3 lots of 2, like as in 2 times 2 times 2. There are 3 2's all being times together. You actually would have seen this, either in year 7 or year 8 at some point with the numbers. What might be new for you, and what the majority of this topic in year 9 is all about, is the algebra when you have unknown numbers. So for example, here we have x, some number, we don't know the value of it, which is why we're calling it x, but there's some number which is taken to the power of 4. Oh good, he's leaving. So in this case, x to the power of 4, the way you'd write that in expanded notation is x times x times x times x. So that's that one. That's writing out in expanded notation. So pretty simple, right? I've got a few extra ones. They don't necessarily get much harder, really. Oh, okay, here, question 3. I'm sort of combining the first 2 questions together. Here we got 2 separate bases, each with their own indice. So here we have 5 to the power of 2. That means in expanded notation, 5 times 5. And that's been times by n cubed, which means n times n times n. So that's question 3 done, right? That's it. Expanded notation is not asking you to do anything with it. We can't evaluate what it is anyway, because we don't know what n is. So that's all we need to do. We're just expanding it all out. The next one, expanding this one out. Okay, that's 7. Now, hopefully you remember from the last lesson that 7 does actually have a index, and that index is 1. So that means there's just a solitary 7 there by itself, and it's been multiplied by x squared, or x to the power of 2, which is x times x. So that's question 4, written expanded notation. And the final one, you just got a normal 2 by itself, right? A base 2. You've got a squared, so that would be a times a, and you just got b to the power of 1, so it's just like a solitary b there. That's it for our first lot of examples. Expanded notation, that's how you do it. There's not really much else to it. It's, again, pretty simple. So if you haven't yet, pause the video, make sure you get this copied into your books. Once that's done, unpause the video and make sure you got these 3 examples in as well. Now that's done, we can move on to the next part of the lesson, which is now writing things in index notation. It's just the opposite of what we just did. So in this case, I'm going to give you, again, I think I've got 5 examples, all written out currently in expanded notation. And so we're just going to, do the opposite, write it out in index notation. So this first one here, you got 3 times 3 times 3 times 3. How can we write this in a more simplified way using index notation? Right, so this is just 3 to the power of 4. Again, note that the question's not asking us to evaluate. It's not asking us to actually find the answer. If they did ask you to evaluate, again, that wouldn't be a challenge, just 3 times 3 times 3 times 3, you just type it into your calculator if you wanted. It wouldn't be hard, but no, that's not what this question's asking you to do, right? It's just asking index notation, so don't find the answer, just rewrite it using an index, right? So hopefully that makes sense. This one here, again, we're going to rewrite this using an index. So 2 times 2 times 2, right? I can combine these. Say, hey, that's 2 to the power of 3. 2 to the power of 3. And it's been times by, here we have 5 times 5. That's 5 squared. That's it. That's as much as you can do using index notation. Some people might be super tempted to multiply these 2 bases together to get like a 10, and then they might sort of guess what they're doing with the powers, whether they're adding them or timesing, whatever. But that's not right. 2 and 5, they're different bases. They don't simplify together like that. This here is your answer, right? This here, that's your answer there. That's it in index notation. And again, if you've got a really good memory, you may actually sort of recall doing questions like this, or if you're at our school last year, it would have been last year, but some schools might even cover this particular skill in Year 7. You may have seen this already. What might be a bit new for you is, the algebraic side of things, these final 3 questions. All right, so writing these in index notation, and again, it doesn't make it any harder. It's all the same. A is some number. I don't know the value of it. You don't know the value of it. That's why it's called A, right? We've just given it a name. We have A times A times A. In index notation, that would just be A cubed, or A to the power of 3. However you choose to say it, that's up to you. This next one here is interesting. You have A times A, right? That's going to be A squared, right? I'm combining these. And B times B is B squared. So you could have your answer as A squared, B squared. That's perfect, full marks. Alternatively, since both A and B have both been squared, you could also write it as AB all squared, right? With that brackets there, what that means is that squared, that power of 2 up here, is applied to everything inside the brackets. So I don't want to necessarily confuse you. If you understood this and that's perfect, that's actually the way I would have wrote the answer. But I am definitely just wanting to illustrate for those that are really following along and finding this quite easy. A squared, B squared, or AB all squared actually mean the exact same thing. They're just 2 different ways of writing it. All right, and on to the final example for our index notation. Here we go. We have x times y times y times y. So in this particular case, what do we end up with? Well, we have x just on its own. I can just leave this as x, or if I really want to, write as many powers as possible, I could put a 1 up there. It's totally up to you. I personally wouldn't. We've got an x, and here we have a y cubed. Right, note that 3 there, or that index of 3, is only attached to the y. If that 3 was going to be attached to the x as well, you'd have to actually manually write a 3 there, which of course would be wrong for our question, or put those brackets around it, meaning everything's been taken to that power of 3. But as it stands, this is the correct answer here. We just had one solitary x, so write it as x, or an x to the 1 if you prefer, and there's a y to the power of 3. So that's our index notation. All right, and I actually thought I forgot to put in questions at the end. All right, so if you haven't yet, definitely pause the video and copy in your examples for index notation. So you should already have the examples in for expanded. Now let's get in our 5 examples for index. There's the actual question and the first 2. And here's the final 3. Once you have all of them in, we're just about finished with the lesson. Just a little bit of practice for you guys to do yourselves. So let's crack on over. All right, so there's 2 questions in total. Here's the first one. There's just 3 parts to it. Write an expanded notation. I'm going to get you to copy this down into your books. Have a go at answering it. Once you're done, we'll pause the video, have a go at doing that. Move on to the next one here. Write in index notation. Again, pause the video, have a go at answering these questions. Once you're done all of the questions, unpause the video from this point and I'll put the answers up for you and you can see how many you got right. Okay, so do you understand expanded notation? If so, you should have had for the first one, k times k times k times k times k. Apologies for putting the number 5 there. It was actually extremely painful and boring just writing k 5 times. But there it is. I guess, I got through it. So that's the important thing. The next one, we've got a cubed b. So expanded notation, a cubed means a times a. B to the 1, right, is just a solitary b on its own. And this one here, 7a squared, you got 1 7, and there are 2 a's being times together. So they're your answers for the first 3, so definitely go through, mark your work. Hopefully you got them right. If not, you know what to do. Feel free to look back over this video, the section that you need to rewatch, ask questions. Don't hesitate to ask for help if you need it. And the final question, I'm going to get you to write this in index notation. So your answers, you should have had w to the power of 2 or w squared. Down here, n times n times n should have been n cubed. These are meant to be s's. I always struggle to make sure they don't look like a 5. But yeah, they were meant to be s's. So it should have been n cubed times s squared. Or what actually would have been better to do is just write n cubed s squared. You actually don't need that times in between. When dealing with algebra, if you have 2 pronumerals right next to each other with nothing in between, that actually means times. So I actually do have a slight preference for you leaving your answers like that one there. With that being said, if you wrote your answer like this, you actually would still get full marks in an exam, but yeah. And the final one, you should have had 9x squared y. Or if you wanted, you could have wrote y to the 1. That's totally up to you. All right, that's kind of it for this lesson. Right, expanded notation and index notation. Hopefully this makes sense. If not, feel free to rewatch the video. Feel free to look for additional videos on YouTube. There are lots of people, that create videos and some that are way better than my own. Let's be perfectly honest here. But yeah, feel free to do what you need to do. Definitely ask questions if you do have anything you're a little bit uncertain about. And I hope it's all going good. I hope you're enjoying the topic so far. And I'll see you for the next one.